Welcome. All right, so today we are going to add and subtract radical expressions. And we are saying that two or more radical expressions that have the same indices and the same radicand are called like radicals, also like radical terms. Here are some examples. The square root of 7x and 2 times the square root of 7x. These are like radical terms because in both cases there is a square root and the radicand is 7x. 4 cubic roots of 10 and 9 cubic roots of 10, both are like radical terms because you can see here that this is the cubic root of 10 and here this is also the cubic root out of 10. So if we have like radical terms, then it's really the same thing what you have done before when we were simplifying polynomials, and we are doing the same thing. For instance, if I have 2x and I want to add to this 3x, we said that these are like terms, and we could just say, one moment, at that moment this is 2 plus 3x, which will be just 5x. You just add them. It's like comparing apples with apples and not apples with oranges. So let's go ahead and do this. I have 9 times the cubic root out of 7 minus 4 times the cubic root out of 7. These are like radical terms. They are both having a cubic root and the radicand is 7. And that means what you are really doing here is factoring, if you haven't noticed. I am factoring out the cubic root out of 7. And I have 9 minus 4. Well, 9 minus 4 is just 5. And that is already it. 5 cubic roots of 7 is left. I had 9 of them. I took 4 away. I'm left with 5. All right, so this one was fairly simple. The next one, well, there is an extra additional step that we have to do. Because as is, I cannot subtract these ones. The radicand is not the same. In the first one we have 12x, in the second one we have 27x. So, but of course, they want us to see something. They want us to see that 12x is the same thing as 4 times 3x. And 27 is the same thing as 9 times 3x, 27x, 9 times 3x. So, in other words, we are doing again what we have learned in the last section. We are simplifying these radicals. So, I have 3. The square roots of 4 is 2 times the square roots of 3x. Minus 6. The square roots of 9 is 3 times the square roots of 3x. And now I multiply this out. 3 times 2 is 6 times the square roots of 3x minus 6 times 3 is 18 square roots of 3x. Now they are like radical terms, and that means now I can say this is 6 minus 18 square roots of 3x. And 6 minus 18, that is a negative 12 square roots of 3x. So I had to just manipulate the radicands before I could actually subtract these ones. Let's have a look at the quotient rule for radicals. This is really actually nothing new. This is really nothing new. The nth root out of a divided by b is nothing else but the nth root of a over the nth root of b. Look where this really comes from. Quick reminder. A raised to the 1 over n, that was nothing else but the nth root out of a. So we had a rule here that a over b raised to some power, the power goes to the top and to the bottom. This is the same rule as always for exponents. And what is it that I just wrote there? Well, this is the nth root out of a over the nth root out of b. So I hope that this helps you to remember this rule right here, because it really is nothing else but our a over b raised to the n is equal to a over n divided by b over n. Let's use it. We have the square roots of 50x cubed divided by 81y to the 8th. The first thing that I notice, I cannot simplify anything inside the radicand. 81 and 50 don't have any common factors. I have x's on the top and y's on the bottom. So the only thing that I can do here, it's kind of screaming at me, what I'm supposed to do is rewriting it as this. I am splitting these radicals up. And now I look in the bottom. Oh my goodness. Do I need to write down the extra step? Let's do it. Let's write down the extra step. This is nothing else but 9y to the 4th squared. And in the top, I will also have to simplify. 50 is the same thing as 25 times 2. X cubed has an x squared and an x in it. And now I look just first in my denominator. This will be just 9y to the 4th. So in other words, down here, there is no radical left at all. And in the top, I have that this is the square root of 25x squared times the square roots of 2x. And again, the square root of 25x squared will be 5x for us times the square roots of 2x divided by 9 to the 4th. All right. Let's do one more, just like the last one. I have now the 4th root, but I'm going to do the exact same thing. I first break this up into 2 radicals. And you notice in the denominator, the 12 is divisible by 4. And that means down here, I will get immediately x raised to the 3rd. In the top, there is not much that we can do. 13 is a prime number, but y to the 7th has one factor of y to the 4th in it. So there is just a slight little bit that I can split up right here. This is the 4th root out of y to the 4th. And that will be leaving me with just 1y. And the rest that is still there is 13y to the 3rd all over x to the 3rd. All right, so this is more like a puzzle. You just try to find as many perfect pieces as you can. So if we are going to do this whole thing now backwards, that means we are going to take 2 radicals right here, and we are using, that's a bright color, and we are now combining those 2 radicals into 1. So we are going to take 2, we merge them together into 1. Let's do that with this example. I have a square root on the bottom, I have a square root on the top, and that means now I can make one big square root out of this. And I had on the top 54 a to the 7th, b raised to the 11th, divided by 3a to the negative 4 times b raised to the negative 2nd. And the difference here now between this problem and the last problems, on the inside here, I can now do something with this. This can be simplified. This can be written as 1 square root without the fraction. 54 divided by 3. Let's have a look. What is 54 divided by 3? What do we get here? That would be, a moment, 54 divided by 3, my goodness. 54 over 3. That will be, 60 divided by 3 would be 20, so that would be 18. So I have 18. Now with the variables, that's a little bit easier. Top minus bottom, remember that. Top is 7. In the denominator, I have a negative 4. So I have minus a negative 4. B raised to the 11th minus a negative 2. So in other words, I will have the square root of 18. 7 minus a negative 4 is 7 plus 4, and that will be 11. 11 minus a negative 2 will be 11 plus 2, and that will be 13. So what we still have to do now is what we always have done in this section. We are simplifying this radical. I'm going to look at 18. 18 has a factor of 9 in it. A to the 11. 11 has a factor of 10. And b to the 13th. One moment, I need to move this a little bit over. B to the 13. 13 is not divisible by 2, but 12 is. And I have one b left. And now I split this up right here. And I will have the square roots of 9, a to the 10th, b to the 12th will be 3. 10 divided by 2 is 5. 12 divided by 2 is 6. And I still have a little bit left over, the square roots of 2ab. One more example and then we are done for today. The cubic root out of something divided by the cubic root out of something else. I can merge these together. I can make one big cubic root. 48 x to the 7th over times y divided by 6x y to the negative 2nd. And now I'm simplifying on the inside. What do I get? 48 divided by 6. Let's have a quick look. That should be 8. And x to the 7th divided by x. 7 minus 1 is 6. Y divided by y to the negative 2nd. 1 minus a negative 2 is positive 3. And lo and behold, these are all perfect cubes. The cubic root out of 8 is 2. X to the 6th divided by 3 is x to the 2nd. Y to the 3rd divided by 3 is y to the 1st. So this one right here turned out to be really nice.